When a new monitor trips a 20 amp ground fault interrupter circuit breaker, several potential causes need to be investigated. A defective monitor is a strong possibility. Multiple monitors tripping the same circuit strongly suggests a problem within the monitor itself. A ground fault, either within the monitor or its power cord, could be the culprit. This type of fault causes current to leak to ground, triggering the ground fault interrupter protection. Another potential cause is a circuit overload. The monitor might be drawing more current than the 20 amp circuit is designed to handle, leading to the breaker tripping. Loose connections, whether at the panel or at the outlets themselves, can also create intermittent current flow that trips the breakers. Finally, the circuit may be undersized for the total load in the basement. If the monitor's power draw, combined with other devices on the same circuit, exceeds the circuit's capacity, the breaker will trip. To diagnose the issue effectively, several actions are recommended. Firstly, test the bathroom ground fault interrupter outlet. This helps determine if the problem is isolated to the monitor. If the bathroom outlet also trips, it further points to a problem with the monitor itself. Secondly, carefully inspect the monitor for any visible damage or loose connections, particularly on the power cord and where it connects to the monitor. Thirdly, test the circuit with a different appliance that has a known power draw, like a lamp or a fan. If this alternative appliance also trips the breaker, it suggests a problem with the circuit itself, not the monitor. Fourthly, verify that the wiring used for the subpanel and the circuits is of the correct size for the intended load. This involves checking the wire gauge to ensure it can handle the amperage. It's possible that the company selling the monitor might suggest that the breakers are faulty. However, with multiple monitors causing the same problem, the focus should be on the monitors themselves or the electrical circuit they are connected to. Before jumping to conclusions, a thorough investigation is crucial. Here's a more detailed breakdown of the potential causes and how to address them. Let's start with ground faults. A ground fault occurs when electrical current strays from its intended path and flows to ground. In a monitor, this could happen due to damaged insulation on internal wiring or a faulty power cord. Ground fault interrupter breakers are designed to detect even small ground faults and quickly trip the circuit, preventing electrical shock. To test for a ground fault, a specialized tool called a ground fault tester can be used. This device injects a small amount of current into the circuit to simulate a ground fault and verify that the ground fault interrupter breaker trips as expected. If you suspect a ground fault in a monitor's power cord, visually inspect the cord for any cuts, abrasions, or signs of damage. A damaged power cord should be replaced immediately. Now let's consider circuit overloads. Every electrical circuit has a maximum amperage rating, which is determined by the size of the circuit breaker and the wiring used. When the total current drawn by all devices connected to a circuit exceeds its rating, the breaker is designed to trip, preventing overheating and potential fires. To determine if the monitor is causing an overload, you need to know its power consumption, typically listed in watts on a label on the back of the monitor or in its user manual. You also need to know the voltage of the circuit, which is typically 120 volts in a residential setting. To calculate the current draw of the monitor in amps, divide its wattage by the voltage. For example, if the monitor is rated at 150 watts, its current draw would be 150 watts divided by 120 volts, which equals 1.25 amps. Next, add up the current draw of all other devices connected to the same 20 amp circuit. If the total exceeds 20 amps, the circuit is overloaded. Common household appliances and devices can draw significant current. A standard lamp might draw 0.5 to 1 amp, while a space heater can draw 10 to 15 amps. If you find that the circuit is overloaded, you can reduce the load by moving some devices to a different circuit. Another potential cause is loose connections. Loose connections can create resistance in the circuit, leading to heat buildup and voltage drops. This can cause intermittent current flow that trips the breaker. Inspect all connections at the panel, outlet, and within the monitor itself. Make sure all screws are tightened securely. If you find any corroded or damaged wires, they should be replaced by a qualified electrician. In the electrical panel, check that the breaker is securely seated and that the wires are properly connected to the breaker terminals. Use a torque screwdriver to tighten the terminal screws to the manufacturer's recommended torque. This ensures a secure connection and prevents overheating. Now, let's address the possibility of an undersized circuit. In an unfurnished basement, it's possible that the initial wiring was not designed to handle the increased electrical load of a finished space. If the wiring you use for the subpanel and the circuits is too small, it can overheat and trip the breaker even if the total load is below the breaker's rating. The National Electrical Code, or NEC, specifies the minimum wire size required for different amperage ratings. For a 20 amp circuit, the NEC typically requires 12 American wire gauge or AUG copper wire. However, the specific requirements can vary depending on the wiring method and other factors. To determine if the wiring is correctly sized, consult the NEC or a qualified electrician. If the wiring is undersized, it will need to be replaced with the appropriate gauge wire. When working with electrical wiring, always follow safe practices. Turn off the power to the circuit at the main panel before working on any wiring. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, contact a qualified electrician. They have the knowledge, experience, and tools to diagnose and repair electrical problems safely and effectively. In addition to the above steps, it's also important to consider the type of circuit breaker being used. Ground fault interrupter breakers are designed to protect against ground faults, but they can sometimes be more sensitive than standard circuit breakers. If you are experiencing nuisance tripping, it may be necessary to replace the ground fault interrupter breaker with a higher quality unit. However, it's important to first rule out any other potential causes before replacing the breaker. Another possibility is that the ground fault interrupter breaker is simply old and has become more prone to tripping. Circuit breakers have a limited lifespan and can become less reliable over time. If you suspect that the breaker is faulty, it should be replaced by a qualified electrician. When replacing a circuit breaker, make sure to use the correct type and amperage rating. Using the wrong type of breaker can be dangerous and can damage your electrical system. It's also important to label the breaker clearly so that it can be easily identified in the future. In addition to checking the wiring and circuit breakers, it's also important to inspect the outlets themselves. Outlets can become loose or damaged over time, which can lead to poor connections and arcing. Arcing can generate heat and can potentially cause a fire. To inspect an outlet, turn off the power to the circuit at the main panel. Then, remove the outlet cover and carefully examine the wiring connections. Make sure the wires are securely connected to the terminals and that there are no signs of corrosion or damage. If you find any loose or damaged wires, they should be replaced by a qualified electrician. If the outlet itself is damaged, it should be replaced with a new one. When replacing an outlet, make sure to use the correct type and amperage rating. It's also important to follow the manufacturer's instructions carefully. Ground fault interrupter outlets are required in certain locations, such as bathrooms and kitchens, to protect against electrical shock. If you are replacing an outlet in a location where a ground fault interrupter outlet is required, make sure to use a ground fault interrupter outlet. Finally, if you have exhausted all other troubleshooting steps and are still experiencing problems with the monitor tripping the breaker, it's possible that the monitor itself is defective. Even if the monitor is new, it could have a manufacturing defect that is causing it to draw excessive current or to create a ground fault. To test this, try plugging the monitor into a different circuit in a different location, such as in another room or in another building. If the monitor still trips the breaker, it is likely defective and should be returned to the manufacturer for a replacement or refund. In summary, when a new monitor trips a circuit breaker, several potential causes need to be considered. These include ground faults, circuit overloads, loose connections, undersized wiring, and defective equipment. By following the troubleshooting steps outlined above, you can systematically identify the cause of the problem and take the appropriate corrective action. Remember to always follow safe electrical practices and to contact a qualified electrician if you are not comfortable working with electricity. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or troubleshooting. Furthermore, always adhere to local electrical codes and regulations. Electrical codes vary by location, and it's essential to ensure that all electrical work is performed in compliance with the applicable codes. This helps ensure the safety and reliability of your electrical system. If the customer continues to experience issues after these checks, it is best to contact a qualified electrician to further investigate the subpanel circuits and monitor to determine the precise cause of the issue and resolve it safely. Ground fault interrupter circuit breakers are designed to protect against electrical shock by detecting imbalances in the electrical current. These imbalances can occur when current leaks to ground, which can happen if someone comes into contact with a live wire or faulty appliance. When a ground fault interrupter breaker detects a ground fault, it quickly trips the circuit, cutting off the power and preventing electrical shock. Ground fault interrupter breakers are typically required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. They are an important safety device that can help protect against serious injury or death. Circuit breakers are designed to protect against overloads and short circuits. An overload occurs when the circuit is drawing more current than it is designed to handle. A short circuit occurs when there is a direct connection between two wires that are carrying current. Both overloads and short circuits can cause the wires to overheat and potentially start a fire. Circuit breakers are designed to trip the circuit when an overload or short circuit occurs, cutting off the power and preventing damage. Circuit breakers are rated in amps, which indicates the amount of current that the circuit can safely handle. It is important to use the correct size circuit breaker for the circuit. Using a circuit breaker that is too small can cause it to trip frequently, while using a circuit breaker that is too large can allow the wires to overheat and potentially start a fire. It is important to consult with a qualified electrician to determine the correct size circuit breaker for your circuit. Electrical wiring is typically made of copper or aluminum. Copper is a better conductor of electricity than aluminum, but it is also more expensive. Aluminum wiring is often used in older homes, but it can be a fire hazard if it is not properly installed and maintained. Aluminum wiring can corrode over time, which can lead to loose connections and overheating. If you have aluminum wiring in your home, it is important to have it inspected by a qualified electrician to ensure that it is safe. Electrical outlets are designed to provide a safe and convenient way to access electricity. Outlets are typically rated for 15 amps or 20 amps. It is important to use the correct type of outlet for the appliance or device that you are plugging in. Using an outlet that is not properly rated can lead to overheating and potentially start a fire. Ground fault interrupter outlets are required in certain locations, such as bathrooms and kitchens, to protect against electrical shock. It is important to use ground fault interrupter outlets in these locations to ensure your safety. Electrical safety is important. Always follow safe electrical practices when working with electricity. Turn off the power to the circuit at the main panel before working on any wiring. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, contact a qualified electrician.